Yes, good morning. So I'm Albert O'Connor. I have been working as a freelance or Django developer for the last 6 years or so, and this morning I'm going to be talking a bit about async tasks with Django Channels. So what is channels? And I'm hoping by the end of this talk you can answer this question in a few different ways, but I'm going to start with my feeling about what channels is, and I'm going to put on my Apple hat here for a moment and say that it's the most exciting thing to happen to Django since Django. That might be overstating it a little bit, but I hope you'll see by the end of this talk that it is actually one of the biggest paradigm shifts in Django since it was created 10 years ago. So first, some audience sort of expectation setting and warnings. I will not be talking about WebSockets. So if you need to leave, if you want to go to another talk, you can. WebSockets is the motivating example for channels, and there are blog posts, and the main channels documentation basically tells you how to set up WebSockets, and that's totally awesome. But I want to look at channels, using channels for other things, and you can use it for lots of other things. And so we'll be talking about sort of offloading asynchronous tasks. I'm also going to expect that you're familiar with Django. If you aren't, you'll probably still get a good feeling about what channels is and what it can do, but inevitably I'm going to be sort of describing channels in comparison to how Django works. All right, so what is channels? So channels is a third-party library which allows Django to handle more than just plain HTTP requests. And of course, a popular example would be WebSockets, but it can do other things too. It was created by Andrew Godwin, who's well known for working with migrations, originally with the application South, and then eventually it was integrated, migrations were integrated into Django in 1.7. But he got a bit tired of working on migrations, and so he thought he would handle async instead. So it was also supported by a Mozilla open source grant, which is totally awesome. It provided some money to help people like Andrew spend a bit more of their time working on these important projects. So Channels is also an official Django project. I think it's the first official Django project not to be pulled out of Django itself. All that really means is that it's now hosted under GitHub/Django/channels. There was a lot of talk about channels being directly integrated into Django 1.10. 1.10's already been released, but so that obviously hasn't happened. There's still potentially an intention to integrate it into core Django one day, but I think it's actually a bit more compelling to be able to tell the story that something as impactful as channels can exist as a third-party app. And it also means that channels supports Django 1.8, 1.9, 1.10, and obviously into the future. So let's look at the sort of top-level design, sort of the concepts behind channels. So the motivating problem, as I mentioned before, was how do you deal with WebSockets in Django? And you can do it today. You can have a separate server that terminates the WebSockets and then use a data layer to sort of communicate between that and Django proper. But it never really felt like there was first-class support for WebSockets in Django. And so they were trying to work on a way to make that possible. And also, it turned out that it actually enables other things as well. And so the way we solve any problem in computer science is another level of abstraction. And the particular type of abstraction that we're talking about here sort of strangleholds Django and wraps the whole thing. So let's focus on the nature of the abstraction and specifically how channels can support existing Django code in such a natural way. So Django fundamentally takes in HTTP requests, calls a view, your view, it does some processing, and it inevitably returns an HTTP response. So this sort of encapsulates how Django has worked for the past 10 years, and obviously we've been able to do lots of interesting and fascinating stuff with that, but that's the fundamental model. So with channels, it receives a message on a channel, calls a particular consumer, and that consumer can in turn send other messages. So very simple, very generic, but we can see how we can actually take this generic behavior and wrap it around Django, and that looks kind of like this. So you receive an HTTP request message, which in turn calls a consumer. That consumer does basically the same thing that Django does now and calls a view. The view returns an HTTP response, and then the consumer sends a message on a particular HTTP response channel. So there's a lot of stuff in there, but that is the fundamental abstraction. So let's look at that visually to try to break it down a bit more. So currently in Django, you have your browser. It sends an HTTP request over the network. We have a WSGI server that translates that into a WSGI HTTP request. Django does some additional processing on it to make it a native Django request. It calls your view does stuff, you return it, and it goes back up through the browser. So fundamentally, switching to channels looks like this. So instead of WSGI, we have an ASGI server, which we'll talk a little bit more about later. It gets an HTTP response. It transforms it into something that channels understands. It calls a particular view, it calls a particular consumer, the view consumer, which in turn calls your view. But let's look into this bottom section in a bit more detail to see what's going on. So your request comes in over the wire. The ASGI server converts it into a message using the standard sort of message protocol that Channels provides, and it enqueues it on the HTTP request channel on which the view consumer is listening. The view consumer then does a lot of the pre and post processing that Django does for you today, including taking that request and transforming it into a native Django HTTP request. It calls your view does whatever it's always done, returns a Django response. The view consumer then converts that into a message and then sends it on a very particular HTTP response channel that leads it back to the browser. So there is in Channels one HTTP request channel that all requests come in on, but there is not just one HTTP response channel. Each request, when it comes in, part of its message is a reference to the name of the particular response channel that you're supposed to respond on. And this is important so that your rendered HTML page goes back to the right front-end server and then to the correct browser. All right. So in addition to this HTTP request and HTTP response family of channels, Channels provide some other specific channels that you can use, like WebSocket Connect and WebSocket Receive. But that's all I'm going to talk about, WebSockets, because you can also create your own channels. Channels are just named queues on a message bus, and you can bring a channel into existence just by giving it a name, which is kind of like a little superpower. So we're going to create a channel in the example that we're going to go through to handle an async background task. Before we get into the example, though, there are some things to think about with channels. And so whenever someone builds a distributed system, there's always a bunch of trade-offs that they have to sort of make decisions on. And in the case of channels, the goal was to optimize to run something like a chat server, so it's very low latency and very quick. And so one of the biggest things to keep in mind is at most once delivery. So if something goes wrong and Channels has tried to send the message already, it won't try to send it again. A more robust system like Celery does the opposite. It tries to guarantee delivery, but this means that the code needs to actually handle duplicates properly. In this case, you may need additional code to make sure mission-critical things happen. In the end, it's sort of a trade-off. Either way, you have to do a bit of extra work. But this does mean that Channels is more suited for background async tasks that aren't as mission critical. And I think there's a lot of things that fall into that category, certain types of notifications and certain types of processing that you can sort of redo if you need to. Ordering is also something worth thinking about. In order to be as fast as possible, Channels doesn't provide strong guarantees about ordering. If you have a bunch of workers all feeding off the same queue, you can run into some contention that way. But there are some options to enable some types of ordering. Obviously, there's a bit of performance hit there, but if that's what makes sense for your particular project, you can enable it. The key thing here is if you're going to go and do stuff with Channels, it is important to read the docs. They're quite well written, and they talk about these different trade-offs. All right, so let's look at some quick examples of how I've successfully used Channels to do async work already, just to get a sense of the kind of things that are possible. And so here I have a website I built for a client that's trying to collect different implementations of quantum circuits and reversible circuits in sort of a GitHub-like way. And there is a black box Haskell program that one of the researchers wrote that will analyze the source and provide stats about the number of gates and even produce an image of it. And so I want to put that into a separate channel so that it doesn't interrupt the request response cycle of someone uploading a file. And it's the kind of thing that, so you get a bit of a strange behavior because when you first upload the file, those stats will be empty, but if you reload after a few seconds, they will get populated. Another thing I've done a lot is using Slack. Now, Slack actually has a WebSocket API, so you can go even further and integrate on that level. But even just using Slack's basic message sending, I can offload it into a channel and include it during critical operations on a website and know that it won't interfere with the fundamental request response flow. But I can still get, most of the time, like 99% of the time, notifications so that we know what's happening on our website. So that can be really handy. So let's talk a bit about how you actually add channels to an existing Django project. And it's actually quite straightforward. So you start off by pip installing channels, and then you add it to installed apps, which is basically what you do with every third-party application. So it's very straightforward that way. As I mentioned before, channels replaces WSGI with ASGI. And I put replaces in quotes here because you can actually run them beside each other. And if you're running in a high volume situation, that's the current recommended way to do it. So you can have a WSGI server that handles your HTTP traffic and an ASGI server that handles WebSockets and other things like that. But if you're in a lower volume situation, the ASGI server can handle HTTP just fine. It's just not quite as optimized as the existing WSGI servers, though they are pre-1.0 and they do want to get there. Installing channels includes an ASGI server called Daphne, which is implemented in Twisted. And then Django gains a new management command called run worker. And this is how you run a worker that's there to consume messages from the queue. But you can run the management command run server works just as it has for the last 10 years. And they get away with this by running Daphne and a bunch of workers in threads in one process. And so that's kind of handy that you can develop the same way that you've had before, and everything just kind of works. For production, though, you want to use some sort of broker to pass messages between your ASGI server and your workers. And there's an ASGI Redis implementation as well that they have. And if you run a Redis service with that, you can actually have a whole cluster of workers and even a couple of front ends if you want to. And we'll look at that a little bit at the end of this talk. So Daphne is handling the HTTP, the WebSockets, and more, and all it does is enqueue the right messages into the right channels, and then the message bus takes it from there. Your view and consumer code can also enqueue messages into channels, but what this means, though, is that your view and consumer code is written synchronously. So this is really awesome because we can reuse all the view code that we already have, but also when we're writing consumers, we don't have to think asynchronously. Like asynchronous code is really important, but we're able to sort of push it up the stack and have the front end deal with that complexity. And then we just handle our business logic remains synchronous. Though, as in the case with any event-driven platform, you do have to be mindful that your view and consumer code isn't taking too long to execute. Fortunately, if you do have a time-consuming bit of work that you need to do, you can create a channel and offload it onto there. All right, so we're going to go through a quick demo. We're going to go through, so the demo code's available on this GitHub server, though I'll have slides up on my website, and I'll post them on Twitter and stuff like that. But we're gonna, and there's a bunch of tags that sort of go through the different steps so we can see how the code changes and sort of how little you need to actually do to use channels. So the first step is we have a basic Django app which just says hello and it simulates sending a notification. So here's what the code looks like for the view. We have this delay generator which just simulates an unreliable network connection. We have this send notification function that proxies, sending something to Slack or something like that, but we're just going to print it to the console so that we can see that it's working. And then our view says hello world, or you can pass in a name and it'll say hello to you. And so if you grab this tag and run server, everything will work as expected, but it'll take 5 to 30 seconds for your web pages to render because the send notification is being done inline in the request response cycle. So the second step, the second tag, we're just going to install channels and update our settings, but we're not going to actually change any of the view code. So To install channels, you add channels to your requirements.txt file, and then you pip install it, and it installs a whole bunch of things, including Zope interface. So here we are in 2016 talking about the future of async in Django, and Zope is still with us. But this actually shows off another feature of channels. Unlike Django 10 years ago, where they put everything into one package, our packaging systems have evolved a lot, and now it's possible to sort of rely on them. And so Daphne itself really is just a bit of glue code between Twisted and Audubon, and not a lot of novel development needed to be done, and that's actually totally awesome. Okay, so after you've installed it, you need to add it to your installed apps. This gives you access to the new management commands. And then the one setting you do need to set for channels is your channel layers. And this basically tells channels what message broker you're using. And so by default, there's an in-memory one. And then there's the routing setting. So this is much like urls.py and root URL conf. So there's a sort of parallel routing for channels, and it's a bit more generic to be able to handle things like sockets or WebSockets and all that good stuff. So at this point, if you run server, nothing has changed in the experience. It still takes 5 seconds for your views to load. But if you look at your console output, you can see that it's changed relatively dramatically. Now it talks about starting channels, and you can see that there's a bunch of workers listening to handle your requests. All right. So step 3 is creating a channel and using it. So here we're going to alter our view code. We take a bunch of it out and move it into a consumer, which I'll show you in the next slide. But basically, we import channels. We say we're going to send a message, and messages are generally in a dictionary format on the notify channel. And that's all we need to do to use a channel into a view. To make this work, though, we need to update our routes to declare that the notify channel exists and tell the system what consumer to use. We then need to implement our consumer. And so this is just the code that we saw in the view before. We have the same delay simulation, and then we have a notify consumer function. And one of the big differences here is on the last line. Instead of just printing the message, because we're actually passing in a dictionary, it's message key, which matches the dictionary that we passed in here. So now if you run it, the website gets a lot more responsive. You don't have to wait 5 seconds or 30 seconds anymore. But there are only 4 workers, so if you send enough traffic to it, and enough of the workers are handling the long asynchronous task, it will get backed up and start slowing down. Fortunately, we can fix this with the bonus round tag, which is where we set up Redis, Daphne, and run things in separate processes, but you can actually customize a run worker to only listen on certain channels, which will enable our website to remain responsive. So here, to get this to work, you need to install the ASCII Redis library, and you also need Redis running so that it can connect to it. You modify your channel layer setting slightly. You tell it to use the Redis backend, and then there's additional configuration here. You need to specify the host. So by default, I'm just running on localhost. All right. So that should be enough to get run server working again, but it's basically going to perform the same as the last example. To use Daphne, we need to create an asgi.py file, which is similar to a wsgi.py file, if you're familiar with that. This is what it looks like. Very similar. We just set up the settings and then set up the channel layer, which is basically equivalent to a wsgi app. And fortunately, all this sort of glue code exists for you, and you just sort of can copy and paste it as boilerplate. And then to run Daphne, it's very similar to running Gunnacorn or other wsgi servers. You tell it what channel layer to connect to, and you specify a port. So if you run this, your website will hang because there's no one consuming the messages that you've enqueued it to get responded to. So we need to run some workers. So this is where that run worker management command comes in. And you can run as many of these as you like and as many terminal windows as you like, but you'll still eventually get backed up. So there's this additional option with run worker where you can include or exclude certain channels. So if you run a normal worker and then run one that excludes the notify channel, this worker will be as available as possible to respond to your HTTP requests, so your website will respond basically all of the time, and the additional work gets backed up onto the other worker. So that's it. That's the end of our whirlwind tour of channels. So now go forth and write readable async code. And I think we'll have a bit of time for questions as well. Thank you. Yeah. Oh, those warnings were for 25 minutes, not 30 minutes? I didn't need to speed up. All right. I guess we should coordinate it that. All right. So ask away. I've used channels. I'm no expert, but I'll do my best to answer.
So what's the main motivation for using channels versus Celery for certain tasks, particularly ones that don't necessarily have to do with returning an HTTP response?
So I mean, obviously, you can't use Celery to do WebSockets and stuff like that. When it comes to async tasks, I mean, Celery is very robust and very powerful, but I find it a bit challenging to configure all the time if I'm just doing like a small website. And so channels, is hopefully you saw, is very simple to set up, and everything just kind of works. Obviously, there are situations where you should use Celery if you need that. At least once delivery paradigm. But yeah, in this particular case, they do solve similar problems, but they do it in different ways. So it really depends on what your needs are. Any more questions? Don't be shy. All right, I guess we should probably call it. If you want to see the demo in action, I can show it to you on my laptop in the hallway afterwards, or we can chat there. I'll also be in this room for most of the conference as well. So if you've got questions, please feel free to ask them.
All right. Well, thanks a lot, Albert.
Thanks.